Okay, good afternoon, class. Okay, now last lesson we had problems with getting the answers that the textbook had. So we have contacted them, so we're just going to give some clarity on those questions. The first one where the answer is different is number out of exercise 6, no? 5. In exercise 5 was number 4, correct? No, it's not number 4. It was number 5 that was the issue, no? Right. So consider the letters from the word winners. The repeated letters are identical. If the letters are arranged in any order without repetition to form different words, what is the probability that the word form will start with an S and start with a W and end with an S? So I think that calculation we took off already, no? So we said that the probability, calculate the probability, is a number of possible outcomes, favorable outcomes of a number of possible outcomes. So 5a, so you must start with a W. So it's 1, 2, 3, 4, 5, 6, 7. Start with a W and end with an S. So we are left with inner. 1, 2, 3, 4, 5. 1, 2. Yeah. So it will be 1 times, that is 5 factorial, over this 2 repeated letters factorial, times 1, which is 1s. Okay. Number of possible outcomes. We said that the number of possible outcomes in the previous video, we came to 7 factorial over 2 factorial. So the probability is going to be 5 factorial over 2 factorial divided by number of possible outcomes, which is 7 factorial over 2 factorial. Okay? And that gives us an answer of 5 factorial over 7 factorial, which is 1 over 42. Is that correct? That's the answer we had last time, no? Right. And then the B part is still on the board. Okay. So this basically confirms the calculation that they sent us, and here you can see it. So there's the calculation. Okay. So as I said, the answer in the book is wrong. Okay. So they're saying for winners, they got 5 factorial, but we must divide it by 2 factorial for the identical letters. Okay. For n. So the probability is going to be exactly what we had there. Okay. Then for the second one, for B, we also had 2 over 7, and which now confirms the calculation as well. Okay. His handwriting is a little bit better than mine. Not so? Yes, okay. I feel much better now. Okay, and there we also got 2 over 7, correct? Alright. Then number 6, they did as well. So that answer of 1 over 28 according to him is wrong. Just pull this down a bit. Oops. And for our answer, A we got. We go back, what did we get for A? Okay, as part of our calculations still on the board. So so the probability is going to be, you start with the letter W, it ends with G. So The favorable outcomes is going to be 5 factorial over 3 factorial times 2 factorial, which must be divided by 7 factorial over 2 factorial times 3 factorial, which then gives me again 5 over 7. 5 factorial over 7 factorial, which is also 1 out of 42. Is that the answer we got again? Huh? Yes. So that answer is also correct. And in B, our answer is 3 over 7. Correct? And that is now confirmed in his response. That's number 6A. It's 1 out of 42. Okay, so again, winning was considered. We have 5 factorial there. Must be divided by the repeated letters, identical letters, which is 2 factorial times 3 factorial. Okay, so that's your favorable outcomes. Your possible outcomes, again, 7 factorial over 2 factorial times 3 factorial, which is 1 out of 42. That's the answer we got there. Alright. Then B, we got 1 out of 20, 1 out of 7, which is in fact the answer we have there. Okay. So we were right, we were just a bit paranoid, we thought the textbook won't be wrong. Okay. So, I think we did the one on mathematician, eh? Alright, let's look at number 18. I think this, okay, there's a number 9 as well. And that is going to be, so 8 and 9 is going to be the last of this exercise, okay? Let's just wrap this up. Oops. Alright, so now we're looking at exercise 5 on page 324. We are told 4 mathematics books, 3 history books, and I think we did this one. Did we do this one? Yes, okay. Was this answer also different? Was this answer correct according to the book? Okay, one person is talking to me. Right, I'm going to do it anyway. Just see where is the marker now. So what we have is 4 maths books, 3 history books, and 3 science books, and 2 biology books are arranged randomly on the shelf. What's the probability that all the books of the same lands up next to each other? So the number of possible outcomes, how many books are there in total? There's 12 books, not so. So it's going to be 12 factorial over, and we're going to use the, what is the probability that all of this? Okay? So here we're going to have 12 factorial over 4 factorial times 3 factorial times 3 factorial times 2 factorial. Okay? Number of favorable outcomes. So that would simply be what they're looking at, which means to say we have 12 bits. There's 1, 2, 3, 4, 5, 12 bits. All the maths books are together, so it's going to be the maths books together can be arranged in 4 factorial ways. Correct? The history books is 3 factorial. The science books is 3 factorial. The biology books is 2 factorial. So this can be arranged according to 1, 2, 3, 4 factorial ways as well. Okay. Did we do this calculation the same way the last time? Let's check. So the probability will come out to be, yeah, make a mistake here. So it's going to be 4 factorial times 3 factorial times 3 factorial times 2 factorial times 4 factorial. That is over 12 factorial over 4 factorial times 3 factorial times 3 factorial times 2 factorial. I don't think that is right. Let's check. This is number 8. Mathematics 3 is 3 science and 2. Just check something. It's 12 factors. Yeah. Yeah, that's our answer. Okay, so I had to divide this here by this because they never spoke about the identical letters. The books are identical. That's the issue I had. Okay? So that's my mistake here. They did not say that the books are identical books. Remember when it says identical, then we go with this formula here. Not so. So this is simply going to be 4 factorial times 3 factorial times 3 factorial times 2 factorial times 4 factorial over 12 factorial. Which gives you 1 over 11,500. Okay, let's look at the B part of the question. So 8B says, just the history books will be together. Okay, so again we have 12 bits, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all the history books are together. There are only 3 history books, so we'll bind 3 of them. So they can be arranged in 3 factorial ways, times. Okay, so this becomes one entity. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This times 10 factorial. This is the favorable outcomes. That's what they're looking for. So the probability is going to be 3 factorial times 10 factorial over 12 factorial. Okay. So let's see what we get here. 3 factorial times 10 factorial over 12 factorial. 1 over 22, which is the answer they got there, so that makes us feel better now. That one is absolutely correct. Okay. Let's carry on to the next question. The next one is the last one, is number 7. Okay. Sorry, number 9. 7 boys and 6 girls are to be seated randomly in a row. What is the probability that, so we have 6 boys, 6 boys, 7 boys. Where am I seeing 6? 7 boys and 6 girls are to be seated randomly in a row. What's the probability of that? So in the first case, the row has a boy at each end. The row has a boy at each end. So we have, how many bits would we draw here? 30. Okay. So it must be a boy at the end here and a boy here. Okay. Let's check something. Okay, so if it's a boy at each end, then we have one option there and one there. Okay, so what are we left with? We are left with 5 boys and 6 girls. Okay, so they can be rearranged in 5 factorial times 6 factorial ways. So this is your number of favorable outcomes. Okay, so the number of possible outcomes is simply going to be these 13 children or 13 people that needs to be seated, which is 13 factorial. So your probability here would be a number of favorable outcomes, which is 5 factorial times 6 factorial over 13 factorial. Okay, which gives us 1 over 72,000 and 72. Okay, which makes that the answer that they have there. Okay. B says the row has boys and girl. The row has boys and girls sitting in alternate positions. So we got boy, girl, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 12, 13. Okay. So you have a boy, girl, boy, girl, boy, girl. Girl, boy, girl, boy. Why must we start with the boys? Because if you have started with the girls, you're not going to end up with a boy and girl. Okay, you're going to end up with 2 boys at the end. Okay. So how many options do we have for the boy sitting on this position? This boy sitting here? We have 7, not so. Then 6, 5. 4, 3, 2, 1, and so on. Okay? Let's check again. Okay, so if you look at what I have here, it's going to be 7. For if it's alternate, it's going to be boy, girl, boy, and so on, all the way to the end. You must start with a boy and end with a boy, because we have more boys than girls. So what I would have done was I would have said your probability is going to be there are 7 factorial for the boys position times the girls can then be there's 6 girls, so you got 6 options, then 5, 4, 3, 2, 1, which gives you 6 factorial over 13 factorial, which to me would make sense that the answer would be 1 over 1716. But I could be wrong, because if you look at their answer that the textbook has now, their probability that it's working, they say that there can only be 6 factorial ways the boys can sit, the girls can sit in 6 factorial ways over 13 factorial. Okay, and that is how they get their answer of, which doesn't make sense to me, but okay, 1 over 12,012. Okay, that's the textbook's answer. It doesn't, I'm just not sure why they're multiplying it by 6 factorial and not 7 factorial. Okay. Then we have a scenario here where, just put this back. So in C, 2 particular girls land up sitting next to each other. So 1, 2, 3, 4, 5, 6, 7, 13. No? So the 2 girls sitting next to each other. Okay? So they can sit in how many ways? 2 factorial ways. Now there's no condition given for the girls and the boys that's left. Not so. So in other words, that is going to be they are one entity. They can sit in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factorial. Okay, so the probability is simply going to be 2 factorial times 12 factorial over 13 factorial, which is 2 over 13. Okay, I got the answer they got there. Okay, and then the last one. So if we get this one right, all the girls are to sit next to each other. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many girls are there? 6. So we bind 6 seats. 1, 2, 3, 4, 5, 6. So they can sit in how many ways? 6 factorial ways. They become one entity now. So it's 1 bit is 1, 2, 3, 4, 5, 6, 7, 8 times 8. 8 factorial. So it's 6, 7, 8, 9. Okay, so the probability that the girls are to sit together is 6 factorial times 8 factorial over 13 factorial. Okay? So it's going to be 6 factorial times 8 factorial. So it's 2 over 429, which is also correct. Okay? So it's just that B that I'll try and make sense of. And then if I come up with that solution before you guys write your final, I will put it in the group. Otherwise, I don't. Okay, we are going wrong. Alright, so that basically brings us to the end of probability. Okay.